Hello everyone. Recently I've had some free time, so I've taken on part-time work repairing electrical equipment. I'll be recording the repair process and uploading it to my channel. Hopefully these videos can help technicians save time when dealing with similar devices. Today is the first video in this series. A customer sent me 2 small inverters for repair. I'll start with this black unit. The label has been completely removed, so I don't know its rated voltage or power. Let's open it up first. To get started in inverter repair, you'll need at least a soldering station. You can use any model, but I recommend one rated above 60 watts. You'll also need a multimeter, capable of measuring voltage, resistance, diodes, and capacitance. An oscilloscope is a big advantage as well. However, if you don't have one yet, a soldering station and a multimeter are sufficient to begin with. Back to our faulty inverter. Luckily, we can see a 48 volts marking on the main transformer. So for now, we can assume this is a 48-volt inverter with an estimated output power of around 1,200 watts. I'm basing that on the 2 EE42 transformers. Each one can typically deliver about 600 watts continuously. This inverter uses 8 input filter capacitors. The reason for having so many is to reduce the overall ESR, which helps keep the capacitors cooler during operation. It has 8 MOSFETs, evenly distributed across the 2 switching transformers. Each transformer uses 4 MOSFETs, arranged in 2 legs. The MOSFETs are rated at 200 volts and 55 amperes. Next to it is a buck converter module that steps the 48-volt battery voltage down to 12 volts. It powers the PWM control module and also supplies the cooling fan. At the top, you can see the diodes responsible for rectifying the AC voltage from the transformer into DC. This voltage is then smoothed by the 2 high-voltage capacitors next to them. Typically, the voltage at this point is around 400 volts. Next to the capacitors are 4 IGBTs responsible for converting the DC voltage into 220 volts AC. The AC waveform generated by the IGBTs has a very high frequency, so it is passed through a large toroidal filter inductor combined with a mica capacitor for filtering. As a result, we obtain a sine wave at the output, which is then delivered to the socket for use. First, check the fuses. Use the continuity mode on your multimeter. If you hear a beep, the fuse is still good. Next, switch to diode mode to test the MOSFETs in the DC-DC stage. Place the black probe on the drain, D, and the red probe on the source, S. If the reading is around 0.45 volts to 0.55 volts, that MOSFET is still good. Luckily, all the MOSFETs are still in good condition. Next, check the 4 IGBTs in the DC-AC stage. The method is similar. Place the black probe on the collector, C, and the red probe on the emitter, E. If the reading is around 0.3 volts to 0.45 volts, the IGBT is good. Fortunately, the IGBTs are also fine. Now I'll connect the inverter to a 48-volt power supply and see what the actual issue is. I applied a 30-volt input to the inverter, but when I turned it on, there was no response at all. The display remained completely off. After checking, I confirmed that voltage is present after the fuse. However, when I measured the output of the buck converter, there was no 12-volt output. This is abnormal, since the buck converter's job is to step down the battery voltage to 12 volts to power the control circuitry. So the issue is likely in this section. I'll remove the buck converter module and replace its IC. This module uses the XL7056 controller IC. After replacing the IC, the buck module is working again. The output voltage measures 13.7 volts. I'll reinstall the module and test the inverter again. After reinstalling the buck module, the inverter powers up normally. The display shows an input voltage of 51 volts and an output of 220 volts. Next, I'll run it under load for a while to check for any instability or abnormal behavior. I connected the inverter output to a watt meter and a 275 watt lamp. The result shows the inverter is operating properly. I'll continue testing it for about 30 minutes, then reassemble the unit and return it to the customer. In summary, today's issue was in the buck converter module. This prevented the PWM control module from receiving power to start up, similar to a car without a battery. Hope this video is helpful to you.